Hi and welcome back to LPIC 1 series. I am Jadi. I will be glad if you enjoy this series and subscribe. But let's go back to our lessons. We're talking about creating partitions and file systems. In this section, we are talking about what you should do with your new hard disk, your solid state drive, your floppy disk, or any block device you have. Candidates should be able to configure disk partitions and then create file systems on media such as blah blah and handle swap partitions. Objectives are understanding MBR versus GPT partition tables. We will talk about them. Use various makefs commands for different kind of file systems and understand these. Have an understanding of BTRFS. You don't need to use it, but you should have an understanding how cool it is. And also few tools like fdisk and gdisk and parted, makefs and make swap. To continue this lesson, I want to work on my virtual machine first. And also I want to edit my virtual machine. Here I'm using UTM. You can use VirtualBox or whatever. But what I'm going to do is I'm adding a new drive to this machine. So I say new drive, ID, SCSI, whatever. And for example, 4 gigabytes. I added a 4 gigabyte disk to this machine. You can see it here. I will save this. Now this machine has 2 different disks. Why I did this? Because in this section, we are going to talk about partitioning disks. So now I used to have a virtual machine with 1 disk. It was booting and everything was working. I added a new 4 gigabyte disk to this machine. And now I can partition this, format this without interfering with my virtual machine. If you are using any other virtual machine setup, it's very easy. You can find where you can add more disks and work with them. I booted the machine. Later I will SSH. Practically I will connect to this machine. We will see this later. And from there we can work. Let's try it. This should be the machine. I will SSH to it. This is my password, 123, same username. And now we are connected. Before we go any further, let's understand what are block devices. It is just like disks, easy. But block device is a non-volatile. So when system reboots, when the power cuts off, when you turn off the computer, data remains intact. It's not like a memory which you lose data after power cut off. It's a mass storage. When we are talking about mass, practically we talk about megabytes. When they called the floppy disk storage, then they had mass storage, 100 megabytes. Now we have terabytes, even larger ones. So when you have a mass storage, it's non-volatile and accessed in any order. This is important. When you have a classic disk, it's like this. You create sections on it, you create sectors, blocks, and you can read or write from here. A magnetic head will say, woo, I write here. I want to read here. It reads here, then goes here, write something here. You don't need to go one by one. On the older days, we used to have these funny tapes. It works like this. And the head was here. So it was not possible to suddenly read here. So it was not random access. You had to go through all of this data, reach here, and then read this by scrolling these things. But on the disk or SSD is like a small electronic device. It has different parts in the memory, and you just command to it, I want to read this, and you read this. You say, I want to write here, it writes here. You don't need to scroll through all the data to reach some specific place. Anyway, this is a block device. When we are working with block devices in the many operating systems, we partition them. This is the raw SSD you buy. You create a partition table here, and then you create, for example, 3 partitions inside it. This partitioning depends on your hardware, because I'm telling my hardware how to access my storage device or block device. How it works. As I talked in, I think here, maybe, not sure where, but in this section, we have 2 different hardwares nowadays. One is MBR and second one is UEFI. Sorry, one is BIOS, another is UEFI. UEFI is modern one, BIOS is the old one. If you have the BIOS computer, say built 20 years ago, 10 years ago, when the system boots up, it looks to the hardware it has, it finds the hard disks or storages. Inside them, it looks for an MBR, which is master boot record, and starts booting computer from there. So if you have a hardware, you create a partition. One of the partitions is assigned as a boot partition. So this is a boot partition. BIOS will look inside this MBR and will start booting computer from here. If you have a BIOS machine, you have to use a tool called fdisk to partition it. If you have a UEFI machine, the process is different during boot. It's much more complicated, more possibilities. For example, on BIOS machines, you could only have 4 partitions, no more. 1, 2, 3, 4. There were tricks. For example, you could define one of the partitions. These are primary partitions. You could define one partition as an extended partition, and inside that extended partition, create more partitions. So this was more normal to do. You create one primary partition, one extended partitions, and inside that one, you were able to create more logical partitions. Anyway, on UEFI machines, the partitioning is different, so we use a tool called gdisk. fdisk for MBRs on BIOS machines, gdisk for GPT, which is GUID partition table, on UEFI machines. So you have to know both tools depending on your machine. My virtual machine uses BIOS. So practically I have to use fdisk and show you all the process of manipulating everything. First, let's become root, sudo su. I will give my own password. I could do su dash or run everything with sudo. This is easier. I can do ls block. It will show me block devices. As you see, my main hard disk, which I was using, is known as SDB on BIOS machines and in general on Linux. Whenever you have a new block device, it will be known as dev SDA for the first one, SDB for the second one, SDC for the third one. Even nowadays using udev, we've seen this before. From one stage you will start hearing we've seen before, we've seen before, we've seen in previous lessons, and you know that, oh, I'm learning a lot of things. If you remember, on the beginning of the course, we were always saying, we will see this later. Now I'm telling you, we've seen this before. You've seen udev before. Nowadays, as soon as I connect a new, for example, USB disk to my machine, udev will announce it as /dev/sdd. This is a address for the new USB device. The new disk is known as SDA. Normally, I would prefer to have it as SDB and the old one as SDA, but you don't have any control on this. We will see on the last section of today's notes on how to overcome this problem. But anyway, in this case, my new hard disk is known as SDA. It's a 4 gigabyte hard disk. And also I have SDB, which is a 20 gigabyte hard disk, and I was using on my computer. I want to work on this SDA. So I can say this is a BIOS machine, so I have to work with fdisk. I can say fdisk list partitions SDA. It says, okay, the switch is -L. I'm listing the partitions on this device. It says this is a 4 GB hard disk. This is the model. These are the sector sizes and nothing else. So no partition there. I want to create some partitions. So I can say fdisk dev SDA, no -L. So I'm entering fdisk to work on this. It says, okay, I have the fdisk. How can I get help? M is for help. A little bit strange, but remember this as menu. What do I have here? There are lots of commands. For example, -N. Sorry, not -N. N, because you just need to write a command here. N is for new partition, create a new partition. P is for print partition table. Remember, when I did fdisk -L for list /dev SDA, it lists all the partitions on SDA. But when you are inside fdisk, the command is P. L will list known partition types, will give you a long list of all the partition types fdisk understands. So, important ones were N for new, creating a new partition, P for printing partition tables, L lists known partition types, D for delete, A for toggle bootable flag. You remember, on BIOS machines, I told you that when you have different partitions, one of them do have a bootable flag. For example, this one with B. I show it with B, but the command is A. I say, okay, give this partition bootable flag. When BIOS boots, it tries to boot it from this MBR. Anyway, N, new, P, print, A, toggle, L, list known partition types, P for printing partition tables, T, changing partition type, V, verify. Cool. We also have W and Q. Write, quit. So I can say W, write table to disk and exit, Q, quit without saving changes. Let's do some stuff here. I will do a print. Okay, no partition table. I say new partition table, please. It says, okay, what kind of partition you want to create? As I told you, we can have 4 primary partitions, or one of them can be one extended, and inside it we can create more logical ones. The default is primary. It always has a default. So I just push enter. It's primary one. Partition number 1 is good because 1 is default, as you can see. Enter. First sector. My disk has lots and lots of sectors. If it's like this, these are sectors. Or like this with SSD, same logic. I say enter. I want to start from the beginning, as low as I can. This is difficult. So it's okay. I started from here. But what about last sector for the first partition you're creating? I don't know about sectors, but I'm lucky because I can say plus size gigabyte or terabyte or petabyte or whatever, megabyte. So it's easy. I can say I want plus 1 gigabyte. 1 gigabyte after the previous sector I gave you. It's okay, it is done. Created new partition 1 of type Linux and size 1 gigabyte. If I say print, it prints, no, I have SDA1. Let's create another extended partition. So, if you don't remember, I will check the menu. I find N here for add new partition. So I want a new partition, not the default one. I want E for extended partition. Partition number, default is 2, good enough. First sector, whatever. Last sector, default is the last one. So I'm creating the largest extended partition I can. It created it for 3 gigabytes. P. Cool. Now inside that extended, I want to create 2 different partitions. One for swap, one for Linux. Tab. FAT. We'll talk about this later. FAT is a file allocation table. I'm not blaming any geek. Insulting. Anyway, new. Adding logical partition. Now I have to add logical partition 5. Why is that? As I told you, BIOS can have 4 primary partitions. So as soon as you create the first one, it's a 1. Second one is 2, but this is extended. It doesn't use 3 and 4 because those are for primary. So when I create a new partition here, that will be the 5th partition. So default is 5, first sector, whatever, because it suggests the lowest possible one. I'm not wasting any money. The size, I say, okay, 1 gigabyte is good. P. Now I have SDA5, which is around 1 gigabyte. New one. Partition 6. Start wherever you can. Finish on the largest possible partition. Created another one. It's 2 gigabytes. C. I created a 1 gigabyte for Linux. I created another 1 gigabyte for Linux. I wanted to create 1 gigabyte swap. So it would be better if I could create this for 2 gigabytes and this one for 1 gigabytes. Swap is a special kind of partition. When partitioning, you can create one swap partition and it will swap the memory. If your memory is exhausted and system needs more memory, the operating system will start to use this swap partition as an extra memory. Super cool Linux feature. So you cannot resize on fdisk. So I will delete these 2 and create new ones. I did this to show you how to delete. D for delete, or if you don't know, M for menu, and then you have D for delete. I will print. I will delete which one, 1, 2, 5, or 6. I want to delete 5. Print. Now 6 became 5. Delete 5 again. Print. I deleted 2 partitions. New partition. This time I want this to be 2 gigabytes. So start whenever you can, plus 2 gigabytes, and finished. New one. 6, start wherever you can, finish on the largest one you can, and print it. But this is known as the Linux partition, which is the default one. 83, which is known as Linux. You remember, if I go with L, it will list known partition types. So let's try it. L. This is showing me all known partition types, even for BSD, for FreeBSD. A6 is for OpenBSD. Next step, Steve Jobs was working on it. Darwin, and lots of them. But the most famous ones are these ones, which they have aliases. So I can say 83, which is for Linux. 82 is for swap. I can change mine to the swap. Print. I wanted to change this one, right? So I can say M, show me the menu. T will change the partition type. I want to change the partition type. I want to change the 6. What type? It says capital L for least, all. I already know. I can say swap, which is the alias of 82. P. Now my partitioning is done. Time to exit. But I can try the V command, which verifies the partition table, and then do a W to write to the partition table. I will do a verify. It says, okay, no errors detected. You have some unallocated space, which is normal. It's not large. And I'll write it. Now, if I do ls block on dev SDA, you can see that my partitioning is done. Or I can say fdisk -L list partitions on dev SDA. And it says, okay, this is done like this. But remember, I've just created the partitions. I have not formatted them. I cannot use them before I format them with a file system. So we have to go and see file systems on the next section. But before that, I want to show you that if you are working on a UEFI, you had to go with gdisk. On the BIOS, we went with fdisk. On the UEFI machines, we have to go with gdisk. But it's practically very, very, very close. You can see the commands here. First, it has a B, which for backup, which is very cool. It has a D for delete, as we had it. L, list known partition types. N, add a new partition. P, print. W, write. V, verify. T, change partition type. Exactly same as what we did, but on a UEFI machine. There is another tool which is called Parted. This is a GNU tool, and it can edit partitions. People love it because it can resize partitions on the go. Normally we were not able to do this on the fdisk. So people like Parted, but it's a little bit more complicated. As a hint, there is a program which is called gparted, graphical parted. That's what I go for when I want to format a disk. I want to create a USB disk readable with one file format, or most of the things I want to do, I just run gparted. Graphically, it shows a graphical representation of the partitions. You can right click here, format it, delete it, create a new one, drag and drop this one and make this larger if this is empty, and these kind of stuff. It's very, very, very easy to use. It's not part of LPIC because of that. But know about gparted. If you are on a graphical Linux, use it. Even there are recovery distros which you can run on a USB disk or a CD and just boot a computer, use gparted to fix partitioning problems and remove it. It's very, very, very common. Let's close this on the first part, and second we go about on the second part we go about formatting the partitions, understanding file system. We will know about different file systems and how to format disk to them. Be with me, I'm Jadi. I would be super glad if you tell your friends and subscribe.